Hi everyone, it's Scott from Maths Logos, and in this lesson we're going to look at multiplying fractions, and I want to show you quite a few different ways that this kind of question can be asked. So let's jump into our first example. So let's look at simple multiplication just to start with, and when we're multiplying two fractions, we want to multiply our numerators, so I'll do 2 multiplied by 1, and I want to multiply my denominators, so I'll do 3 multiplied by 5. 2 multiplied by 1 is 2, and 3 multiplied by 5 is 15. That's my answer. We then look at 8 multiplied by 1/5. We just want to start by turning 8 into a fraction, and we can do that by writing it over 1, because 8 divided by 1 is 8. We can then use the same principle from before. We multiply our numerators, 8 multiplied by 1, and we multiply our denominators together like this. 8 multiplied by 1 is 8, 1 multiplied by 5 is 5, and I'll leave it as an improper fraction. Pause the video, give these two a go, and then your answers will pop up on screen in a second. Here are your answers. You should have had 3/28 and 3/7 for the second one. Okay, we're now going to look at two examples where we have to simplify our fractions, either at the beginning, before we multiply them, or at the end, after we've multiplied them. Now in our example here, we've got 2/3 multiplied by 6/8, and I could actually simplify this 6/8 as it currently stands, but I'm not going to do that. I'm going to show you what we could do if we multiply them first and then simplify. We'll do 2 multiplied by 6 to give me 12, and 3 multiplied by 8 to give me 24. I can now simplify this fraction by dividing through by the highest common factor, and 12 and 24 have a highest common factor of 12. So I'll divide the numerator and denominator by 12. 12 divided by 12 is 1, and 24 divided by 12 is 2. So that's 1/2. Our next example is individual simplification. In other words, we want to simplify our fractions first before we multiply them. So I can simplify 12 over 36 by dividing through by 12 on the numerator and on the denominator. And then I can simplify 10 over 20 by dividing through by 10 on the numerator and 10 on the denominator. I then get these two new fractions, which I'm going to rewrite so it's a little bit clearer. It's 1 over 3 multiplied by 1 over 2. I can then multiply those fractions together. 1 multiplied by 1 is 1, and 3 multiplied by 2 is 6. My answer is 1/6. Pause the video, give these two questions a go, and then your answers will be up in a second. Let's run through your answers and see how you got on. You should have multiplied these fractions together to give you 12 over 36, and then divide through by 12 on numerator and denominator, and your final answer should have been 1/3. And then for the second question, I simplified the 40 over 90 to 4/9 and the 16 over 40 to 2/5, multiplied the numerators and denominators, and that gave me 8 over 45. If you're enjoying this video so far, I'd really appreciate if you could drop a like on the video and subscribe to the channel. It really just helps us to grow and reach more people. Thank you. If you're using our lesson booklets, you can now complete exercise 1, or you can keep watching this video and complete all your exercises at the end. Okay, let's look at our next example. We have mixed numbers, 2 1/4 multiplied by 3 1/2. Off to the side, I'm going to convert my 2 1/4 into an improper fraction. And the way I like to do this is by multiplying the denominator by the whole number part. So doing 4 multiplied by 2 to give me 8. And then writing that over the denominator. Now what that has done is it's turned the whole number part, 2, into a fraction over 4, because 8 over 4 is 2. I then add on my fraction part, so I'll add on that 1/4, and then I can add 8/4 and 1/4 to give me 9/4. We'll do the same thing with 3 1/2. I'll do 2 multiplied by 3 to give me 6, write that over my denominator of 2. What I've done is I've turned 3 into 6/2, and then I add on my 1/2. 6/2 and 1/2 is 7/2, 7 over 2. I can then come back to this question and I can rewrite it. So I know that 2 1/4 is 9/4, and I know that 3 1/2 is 7/2. I can then multiply my numerators. So 9 multiplied by 7 is 63, and 4 multiplied by 2 is 8. And they have no common factors other than 1, so I'm going to leave it as it is. Our next example is decimal fraction multiplication. So we got 0.2 multiplied by 3/4. And what I'll do is I'll rewrite my 0.2 as 2/10 multiplied by 3/4. And what I'll do is I'll simplify the 2/10 to 1/5 by dividing through by 2 on numerator and denominator. And then I can multiply my numerators. 1 multiplied by 3 is 3. 5 multiplied by 4 is 20. So that's my answer. Pause the video, give these two questions a go, and then I'll run through your answers in a second. Okay, let's go through them. So I'm going to convert 4 1/2 into an improper fraction. So I'll do 2 multiplied by 4, and then add on the 1 to give me 9/2. And then I'll convert 2 1/3 into an improper fraction. I'll do 2 multiplied by 3 to give me 6, add on the 1 to give me 7, and write that over 3. Then I can multiply my numerators together. 9 multiplied by 7, 63, and then 2 multiplied by 3 is 6. 63 and 6 have a common factor of 3, so I'm going to divide through by 3 on numerator and denominator. 63 divided by 3 is 21, and 6 divided by 3 is 2. So that's going to be the answer I'm going to stick with. Our next example, 1.2 multiplied by 5/6. Let's turn 1.2 into 12 over 10, and then we're multiplying that by 5/6. And then I'll do 12 multiplied by 5 to give me 60, and then 10 multiplied by 6 to give me 60. 60 divided by 60 is going to be 1. I'm now going to show you an example using what's called cross simplification. And this is where we can simplify our fractions before we multiply them together by looking for common factors on the numerators and the denominators. So I'll show you how this works. I can see that there's a factor of 2 up here on this numerator, and there's also a factor of 2 on the denominator in the form of 8. So I'll divide through by 2 on the numerator, and I'll divide through by 2 on the denominator, like that. I also spot that there's a factor of 3 on this numerator and on the denominator down here in the form of 9. So I'll divide through by 3, give me 1, and I'll divide through by 3 to give me 3. I'm just going to rewrite these fractions so it's a little bit more clear. That's 1/3 multiplied by 1/4. And I can then multiply those in the same way I normally would. 1 times 1 is 1, 3 times 4 is 12. And that's my answer. We can then extend this principle to multiplying 3 fractions. Let's pick this factor of 2 and divide through by it. And then I could divide through by 2 on the 10 or the 6, but not both. Let's divide through by 2 on the 10 to give me 5. I'll then divide through by this 3 on the denominator and this 3 on the numerator. I have to be careful because I can't divide through by 3 on the denominator and think that I'm simplifying my fractions by dividing through by the 3 on the 6. When we're dividing through by a factor, we need to do it on the denominator and on the numerator, not on the denominator and the denominator, or on the numerator and the numerator. Let's rewrite these fractions so they're a little bit more clear. This is 1 over 1, so I'm just going to leave that as it is. This is now 3/5, and this is now 5/6. And I can apply this principle of cross simplification again. I've got a factor of 3 here, so I'll divide through by it, and I'll divide through by the factor of 3 down here to give me 2. I can then divide through by a factor of 5 here, and also down here. This fraction is 1 over 1, which is just 1, and we're left with a half. My answer is 1/2. Pause the video, give these 2 questions a go, and then we'll run through them. Okay, let's look at this example of cross simplification. I can see that 14 and 21 both have a factor of 7, so I'm going to divide through by 7 to give me 2, divide through by 7 to give me 3. And 5 and 15 have a common factor of 5, so I'll divide through by 5 here, and I'll divide through by 5 here. I'll rewrite this so it's a little bit more clear. That's 2/3 multiplied by 1/3. I want to be very careful here because I cannot divide through by a factor of 3 here and a factor of 3 here, because remember we said it needs to be on the denominator and on the numerator, not just on both of the denominators. So I cannot do that. Instead, what I need to do is I need to just multiply my numerators together. 2 multiplied by 1 is 2. 3 multiplied by 3 is 9. And in our second example, I can see that I've got a factor of 7 here on the numerator and either here in the 14 or here on the 21. And I want to divide through by 7 on the numerator and only divide either the 14 by 7 or the 21 by 7, but not both. Let's go for the 14 to give me 2. I'll then divide through by this factor of 3 to give me 1 and divide through by that factor of 3 here to give me 3. Let's rewrite it so it's a little bit more clear. I've got 1/3 multiplied by 1/2 multiplied by 3 over 21. And let's divide through by this factor of 3 on the numerator and on the denominator here. This fraction 1 over 1 is just 1, so I'm not going to rewrite that. I have a half multiplied by 1 over 21, like this. I'm then going to multiply my numerators. 1 multiplied by 1 is 1, and 2 multiplied by 21 is 42. That'll be my answer. If you're using our lesson booklets, you can now complete exercises 2 and 3, or you can finish watching the video and complete them all at the end. Okay, let's look at our next example. Show that 5 over 2 multiplied by 0.4 multiplied by 0.6 recurring is equal to 2/3. Let's start by turning all of these into fractions. So 5 over 2 is already as a fraction. 0.4, just quickly off to the side, I'm going to say that that's 4/10, but I can divide through by a factor of 2 on the numerator and denominator to give me 2/5. So I'm going to write down my 2/5. And then I'm going to multiply by 0.6 recurring, and I just need to know this, that 0.6 recurring is 2/3, like that. Now what I can do is I can do some cross simplifying, so I'll divide through by a factor of 5 here, and divide through by a factor of 2 on the numerator here, and on the denominator here. What that leaves me with is 1 multiplied by 1 multiplied by 2/3, which is just going to be 2/3. So I've shown that question. Pause the video, give this one a go, and then we'll have a look at it. Okay, let's run through it. Show that 3/7 multiplied by 0.3 recurring multiplied by 1.4 is 1/5. Let's start by writing each of these as a fraction. So we've got 3/7 multiplied by 0.3 is 1/3. And then 1.4 off to the side, I can say that 1.4 is 14 over 10. But we can simplify that to 7 over 5. So that's what I'm going to go with, like this. Then we'll do some cross simplification. So I'll divide through by my 3 numerator and on the denominator. And I'll divide through by the 7 that I see on the numerator and this 7 on the denominator here. And again, that leaves me with 1 over 1, which is 1, multiplied by another 1, multiplied by 1/5. So this would be equal to 1/5. And I've shown what they've asked me to show. Our last example is a worded problem. Let's have a look at it. Sarah ate 2/3 of a pizza. Tom then ate half of what remained. What fraction of the whole pizza did Tom eat? Give your answer as a simplified fraction. Let's start off by drawing a quick diagram of our pizza. And if Sarah ate 2/3, then I want to split this pizza into thirds. That roughly shows the pizza split into thirds. And if she ate 2/3 of it, then this is gone, and so is this third as well. So there's 1/3 remaining. Tom then ate 1/2 of what remained. So of the third remaining, you could think that he split that in two, and he ate half of it. Okay, so that's what's happened. Now you might be able to see that 1/6 remains. But let's show that using our fractions. If Sarah ate 2/3 of the pizza, and Tom then ate half of what remained, well, we want to think, well, what fraction remained? Well, if she's ate 2/3, then 1/3's left over. And so he had this 1/3 of a pizza, and then he had half of it. So we could actually multiply these fractions together to give us our answer. 1 multiplied by 1 is 1, 3 multiplied by 2 is 6. So Tom ate 1/6 of the original pizza. Pause the video and give this question a go. A recipe to make 12 pancakes uses 3/4 of a cup of milk. Amelia decides to make 4 pancakes using this recipe. What fraction of a full cup of milk will she need? So we know that in the original recipe, it makes 12 pancakes. But Amelia wants to make 4 pancakes, which is actually 1/3 of the amount in the original recipe. So she only wants to make 4. And what we can then do is we can use the fact that we know 12 pancakes requires 3/4 of a cup of milk. And because we know we want to make 1/3 the amount of pancakes, we're only going to need 1/3 the amount of milk. So we'll do 3/4 multiplied by 1/3. Let's do that down here. 3/4 multiplied by 1/3. And hopefully you can see you can do a bit of cross simplifying, divide through by your factor of 3 on the numerator and on the denominator, and you're left with 1/4. So if 12 pancakes required 3/4 of a cup, 4 pancakes only requires 1/4 of a cup. You're now ready to complete exercise 4 if you're using our booklets. Thank you for watching this video.